All right, so we're going to find voltage. Remember, this is sort of an introductory couple of videos to show you how to look at circuits and analyze them and find the different parts. Now, yesterday, or the other video, the previous video, we looked at finding current in a circuit. And don't forget, it's very diagrammatical. We're going to be using some Ohm's law equations very shortly, but for now, it's just looking to see how the rules work. So yesterday we saw, or in the previous video, we saw that current is the same everywhere in a series circuit, and the current gets split up if there is a parallel circuit. So today we're going to look at voltage, and you'll see there's a couple rules similar to that, a couple, well, I guess we'll call them rules. And that is what we're going to be discussing today. So right now I have a familiar looking circuit. It is a series circuit, and we have 3 amps going this way around the circuit. We have a 5, how do I say this? The resistor here, if you measure the potential difference across it, is 5 volts. This resistor, the potential difference or voltage is 3 volts, and the voltage at this resistor is only 2. So the question is, what is the total voltage? And the way it works, remember, voltage is electric potential. In other words, the battery raises the energy level of the electrons. It applies a pressure. It causes the electrons to be smushed together in a way that they're repelling each other, and it's going to push them through the circuit. So on the one side, on the one side of the battery, or a power supply, you're going to have a high pressure, high voltage. And then on the bottom, on the other side of the battery, the other terminal, it's going to be down to relatively zero voltage compared to the other side. So think of the power supply or the battery like an elevator that lifts the, we'll just call them electrons, the energy of the electrons to the maximum. And that's the question. What is the maximum? How high are these things being lifted in this case? What is the highest voltage here? And then what happens is, as the electricity flows through the different components, the voltage level drops. So in this case, the voltage level drops 5 volts, and then 3, and then 2, and it will become basically 0. And so what is the total starting voltage? Okay, think of it like an elevator. You went up to a certain height, and then you went down 5 stairs, and then 3 stairs, and then 2 stairs. Well, how high were you originally lifted up? So in this case, 5 plus 3 plus 2, that means that the original, or we'll call it the, we could call it the V0, or the V, in this case, V total, is going to be 10 volts. Okay, so that's how voltage works. In a series circuit, the sum of all the volts basically ends up being the total voltage. Okay, now of course, things are going to be different when we get to a parallel circuit, but in this case we have another series circuit, and we're starting with 9 volts. So the voltage is lifted up to 9, we'll say, from one side to the other. So the electrons come into the bottom floor and they get lifted up to 9 volts here. Okay, and then again, for the analogy, they're walking down the hall and they're going to go down some stairs, and then they're going to go down some more stairs, and they're going to go down some more stairs, and then they're going to come back around to the elevator to get lifted up to the highest point, 9 volts. So if it goes down some stairs, and then it goes down 3, and then goes down 2. Well, what is this voltage? Well, the voltage here is going to be, it's going to have to add up to 9 basically, because you go down 3, you go down 2, so you went down 5. How much more are you going to have to go down in order to basically total out to 9? So this has to be, I almost wrote 9, 4 volts right here. Okay, so in other words, the electrons get lifted up. The total is 9 volts. It goes down 4 at this resistor. It goes down 3 here, and it goes down 2 here for a total of 9 volts. So just check my math here. 4 plus 3 is 7, plus 2 more is 9. Okay. Now for a parallel circuit, it's a little bit different, and actually a little bit easier. Well, let's just put it this way. In some ways it's easier as long as you remember the rules and perhaps why. If we look at the analogy of the battery or the power supply being a an elevator that lifts up our electrons to the highest energy level, then our electrons get lifted up to 9 volts here. And so as the current is 9 amps, that has not anything really to do with it. But as those electrons get pushed down the wire at 9 volts, so 9 amps worth of current getting pushed down the wire at 9 volts of electrical pressure, we'll call it. Well, what happens? Well, some of the electrons get split off going down this way, and then some of those that went down this way go that way, others go this way, and some others went this way originally. So think of it like you are on the top floor and you go around the corner and you have a hallway, and you could, or a split in the hallway, a crossroads, I guess we would call it. And some people go this way and down, some people go straight, some people turn right here, some people just keep going down. No matter what, wherever you're at, you're still at 9 volts. You haven't gone down at all yet, okay? Now, everybody goes down, well, a third of the people or electrons goes down, for the analogy here, down these stairs, and they go around. Now they're on the bottom. They don't go down anything else. They just continue down, and they're on the bottom floor, and they continue all the way around. And they end up, back at the battery. They get lifted up. So everybody does this. Everybody does this. They go down whatever choice they chose, and they're down at the bottom floor. So what does that mean? How far do they go down? Well, what it means is they all went down 9 volts there. They all went down 9 volts there, and they all went down 9 volts there. Okay. Now, the analogy maybe helps understand why, because it goes from high energy down to a low energy. And again, this is introductory. This is just to kind of start to see the picture here. But that's it. So in a parallel circuit, the voltage drop for every path is going to be the same. So let me say that again. In a parallel circuit, voltage is the same. Why am I so tilty? Same for every branch. Okay. And notice I use the word branch there. So what I mean by branch is just this branch, and this branch. Okay. If we had multiple resistors there, then it would be like the total would be the same. Okay. So let's go on here. Well, here we have a combination circuit. All right. We have 10 volts is our maximum. It raises up to 10 volts. And here we have a question mark, and here we have a question mark. What do we do? Well, this one is not a question mark. So we know that going from here to here, the voltage drop is 8 volts. All right. These are in parallel. Remember what I just said. In parallel, the voltage is going to be the same. Because if you think about it, wherever you're at here as an electron, you're going to drop down the same amount because, well, I mean, that's how it works. For a parallel branch, they're going to be the same voltage. So what that means is this is going to have to be 8 volts. All right. Because, well, that's how parallel, I'm saying this badly. That is how components wired in parallel works. Okay. These branches are going to be the same drop from either there to there or from there to there. 8 volts. Well, we started at 10 volts. So if we lose 8 volts here, how many volts did we go down here? If you said 2, that is the correct answer. Okay, 2 volts here, and then 8 volts for. So now that doesn't add up to 10. You say that adds up to what? 16 plus 2, 18. That's okay. Now think again how this works. How is this sum? It's not just adding a bunch of voltages together. How does this work? You got 10 is the total. You lose 2 here. Okay, everybody goes down these steps, so to speak. If you get out the elevator, you're on the top hallway, everybody goes down these steps. But then at this point, you get a choice. You could either go down that way or that way. You don't do both. Just like, if you're in a building and you can go down some stairs or other stairs, but you don't go down both stairs. Okay, both sets of stairs. And either choice you make, you're going to go down the same amount of stairs and end up, in this case, at the bottom floor. Okay, so 8 plus 2 gives you 10.